Hi sir, good afternoon to all of you. This is K. Ishwan from CSC Data Science second semester. Uh, Today I want to discuss about the earthquake detector, which is belongs to the electrical and electronics engineering subject. Let us we go to the topic earthquake detector. What is the introduction? What is an earthquake detector? Now we have to see in the presentation. Introduction to earthquake detectors. Earthquake detectors are instruments designed to sense seismic activity. These devices play a critical role in monitoring earthquakes to enhance the public safety. Understanding how they work can help us appreciate their importance in disaster management. Earthquake detectors are used to detect the uh, when the earthquakes are appeared, and these devices are play a critical role in monitoring earthquakes to enhance public safety. For the public safety, the government has introduced the earthquake detector. Next year, in the PPT we have seen that earthquake monitoring systems live demo as earthquake detection. SSW43, the new released seismic switch as a triaxial accelerometer which helps SSW43 detect earthquake precisely. The built-in algorithm can also eliminate non-earthquake vibrations and make it more reliable. Further, the DO function is designed for emergency disposal that protection users properly. The earthquake detectors are the instrument which is designed to sense seismic activity, and it is which is importance in the disaster management system. Next, types of earthquake detectors. These are various types of earthquake detectors including seismometers and accelerometers. Seismometers measure ground motion while accelerometer measures acceleration during seismic events. Each type serves a specific purpose in earthquake detection and analysis. There are two types of earthquake detectors. First one is seismometers and second one is accelerometer. The seismometers which are measure the only ground motion, but the accelerometers are measure the acceleration of the seismic events. Each type serves a specific purpose in earthquake detection. The both are equal and a specific purpose in earthquake detection. How earthquake detectors works? Normally, the earthquake detectors utilize sensors that respond to vibrations in the earth. When seismic waves travel through ground, these sensors convert the vibrations into electric signals. The signals are analyzed to determine the location and magnitude of earthquake. The how the earthquake detector work? Because when the seismic waves are travel through the ground, then these sensors convert to the vibrations into electric signals. Already some of the sensors are attached to the ground, so when the seismic waves are traveled from the ground, the sensors are converted into vibrations into the electrical signal. That's why automatically we can detect the earthquakes. Components of an earthquake detector. Key components include sensors, data acquisition systems, and software for analysis. Sensors are often placed underground to minimize interference from the surface noise. The data acquisition system collects and stores information for further analysis and reporting. The key components which are included in the earthquake detectors is sensors and data acquisition systems and software analysis. For the analyzing of total earthquake, we have to one of the software analysis. Sensors are often placed underground, minimize interference from surface noise. The sensors are placed in the underground because of the vibrations are came from the ground to the earthquake detector. It can convert the electrical signal. Next, the role of seismology. Seismology is the scientific study of earthquakes and propagation of seismic. It is very important for us. What is the seismology means? Seismology is the scientific study of earthquakes and the propagation of seismic waves. Earthquake detectors are essential tools in the field of seismology for data collection. This research helps scientists understand earthquake patterns and predict the future events. Earthquake detectors are mainly used to understand the earthquake patterns and predict the future events. Upcoming the earthquakes also automatically generated through the earthquake detectors. It is the totally the role of seismology. Seismic waves, primary waves, secondary waves. There are two types of waves in seismic wave. One of the first one is primary wave. Second one is secondary wave. Here the one of the visualization as shown on the PPT presentation is epicenter and light liquid outer surface and solid inner core, shadow zone and shadow zone mantle crust. The under the ground there are some of the surfaces. First one is mantle crust, mantle, inner core, outer core. These are the totally the diagram of the seismic waves. Next, applications of earthquake detectors. Earthquake detectors are used in early warning systems to alert population before shaking starts. When the earthquake means the shaking of the earth into by the breaking or cracking, earthquake detectors are used in early warning system to give the warning. Earthquake detectors are used because of to alert the populations before the shaking start. They are also crucial in building design to ensure structures can withstand seismic forces. Additionally, they help in research and education about earthquake risk and preparedness. Early warning systems. Uh, Early warning systems rely on earthquake detectors, providely time alerts, and these systems can give people seconds to minutes of warning before shaking begins. Such alerts can save lives and reduce injuries by allowing people to take over. Why the early warning systems is early warning systems are rely on earthquake detectors to provide timely alerts to give a alert for the people. The earthquake detectors are used and to give early warning. These systems can give people seconds to minutes warning before the shaking has been begun. Such alerts can save the lives and injuries by allowing people to take over. What are the challenges in earthquake detection? There are some major challenges in the earthquake detection. One major challenge is the ability to accurately predict the timing and location of earthquakes. Environmental noise can interface with the signals collected by the detectors. Continuous advancements are needed to improve detection accuracy and reliability. Commonly, we have seen the earthquakes in some of our India and other countries are like China or Japan, any other countries. One major challenge is ability to accurately predict the timing and the location of the earthquakes. It is very difficult to the all earthquake detectors to predicting of the timing and the location, exact location of the earthquakes. Environmental noise can interfere with the signals collected by detectors. Continuous advancements are needed to improve detection accuracy and reliability. Innovations in earthquake detections. So reduce that the type of challenges. There are some innovations in the earthquake detection. Recent technological advancements have led to improved sensor sensitivity and data analysis. Wireless technology allows for more flexible deployment and of earthquake detectors. Machine learning algorithms are being integrated to enhance predictive capabilities. In recent technological advancements have led to improved sensor sensitivity and the data analysis. Wireless technology allows for a more flexible deployment of earthquake detectors. Next, what are the case studies of earthquake detection? Numerous case studies demonstrate the effectiveness of earthquake detectors in real events. For example, in the 2011, the Japan earthquake showcased the importance of early warning systems. Analyzing these case studies helps improve future detection strategies. Next, recently in the Thailand also the earthquake has been occurred because of due to the loss of early warning systems, the so many lives are spoiled. So that's why the early warning systems are very useful to detect the earthquake. Global network of earthquake detectors. There is a global network of earthquake detectors that share data in real time. Organizations like the United States Geological Survey USGS coordinate these networks. This collaboration enhances our understanding of seismic activity worldwide. For earthquake detectors, there is one of the global network which is used that share data in the real time. Organizations like USGS coordinate this total network. This collaboration has enhances understanding the seismic activity worldwide. Next, are you ready for an earthquake? Preparedness is key. Before an earthquake and during an earthquake, when you feel the quake, there are some of the ODPEM as issued that one of the key and awareness for earthquake. Community programs educate the public about earthquake preparedness and detection. Local government often provide resources to install personal earthquake detectors. Engaging communicating helps foster a culture of safety and resilience. Future trends in earthquake detection. There are some of the future trends in the earthquake detection. Future trends include the use of IoT like Internet of Things devices for a real-time data collection, enhances connectivity with enable faster data sharing and response times. Ongoing research on earthquake prediction model aims to reduces uncertainty in forecasters. Then finally, the overall conclusion is earthquake detectors are essential for monitoring seismic activity and enhancing safety. Continued advancements in technology will improve their effectiveness and reliability. Investing in earthquake detection systems is vital for protecting lives and infrastructure. Next, earthquake detection systems are mainly vital for the protecting the lives and the infrastructure and the geographical area of that country or any that place. Next, questions and discussion. Thank you for your attention. I welcome any questions you may have, and let us discuss how we can further improve our understanding and preparedness for earthquake. This structure provides a comprehensive overview of earthquake detectors while adhering to your guidelines. Thank you for giving this an opportunity to describe about the earthquake detectors as a briefly in this session. Thank you.